What if you could stand up a real, production-shaped .NET service, value objects, a state machine, versioned APIs, authorization, optimistic concurrency, and outbox in about 45 minutes and not write the code yourself? That's what this is. Not a hello world, a real order management service built by an AI on a framework called Trellis. Your job in this lab isn't to type it. It's the more valuable job to read it, run it, and review it to judge whether the machine actually got it right. So this isn't a tutorial you watch, it's a run you can reproduce. We'll scaffold a project, hand an AI the same business spec a product manager would write, watch it implement the whole thing, and then do the part that matters. Open the code, run the endpoints, and grade it against a checklist, honestly, including the places it slips. Let's build. 2 minutes of context, because the whole run makes more sense with it. Trellis is a .NET framework for building enterprise services, and it has a point of view. First, expected failures are values, not exceptions. You compose result and maybe pipelines, so the happy path has no try-catch and every failure is handled explicitly. That's railway-oriented programming. Second, you don't pass raw ints and strings and GIDs around. You model domain concepts as value objects, so a rule like a quantity is between 1 and 999 is validated once at construction, and after that the type itself is the guarantee. On top of that, it ships the domain-driven design building blocks, aggregates, entities, specifications, state machines, and wires cleanly into a SP.NET Core, EF Core, and a mediator. You don't need to know all of it going in, you'll see each piece in the code the AI writes. The services are shaped as clean architecture, 4 layers, dependencies pointing inward. The API layer talks HTTP. The anti-corruption layer talks to the database and the outside world. The application layer orchestrates use cases, and the domain, the value objects, the aggregates, the rules, sits in the middle with no dependency on any of it. The outside adapts to the domain, never the other way around. One consequence to watch for later. The handlers never call save changes themselves. Committing is a pipeline stage the framework owns. Keep that in mind. It's one of the things we'll check the AI got right. And here's the loop we'll actually run. You scaffold an empty project from a template. You hand an AI 2 things, the business spec and the framework's own conventions, and it implements the entire service in one pass. Then the human work begins, and it's the part that builds real skill. You read the generated code to understand the shape, you run the endpoints to see it behave, and you review it against a checklist of what good looks like. Finally, you ask the AI to add a feature to see whether the codebase stays consistent under change. At the end, you have a score, and more importantly, a trained eye. Let's start scaffolding. So look at what actually goes in. First, the spec itself. It describes the domain, the operations, and the rules, the authorization matrix, the optimistic concurrency, the pagination. But notice what it does not contain. It names no classes and no folders. The shape of the code, the layers, the file layout, is the framework's job, not the specs. And second, a checklist, the rubric of what a correct, idiomatic implementation must contain, which is also exactly what you'll grade the result against. Same brief, 2 jobs, a spec for the AI, and a scorecard for you. It all happens in the terminal. Start by scaffolding an empty project from the Trellis template, .NET New Trellis ASP. That single command lays down the 4-layer solution, the build system, and, crucially, the framework's own conventions and API reference for the AI to follow. Next, drop the business spec into the project. It is the same plain English brief a product manager would write, the domain, the rules, and the endpoints, with no code. Now start the Copilot CLI, allow it to run, and give it one instruction. Build the order management service from that spec, following the framework's conventions. That is the last thing you type. From here, the AI does the work. It starts by reading the spec, and the framework's reference docs the template shipped. Then it builds, layer by layer, in the order Trellis expects. Value objects first, so a quantity or a SKU is validated once, at construction, and can never be invalid again. Then the aggregates and the state machine, an order that simply cannot be shipped straight from draft. Then the application layer, a command and a handler for each operation, with authorization and the database transaction applied as pipeline stages. Then the anti-corruption layer, mapping the domain to the database by convention. Then the versioned API. And finally, the tests. What you are watching is around 45 minutes of building, compressed, and notice it is not guessing at the framework, it is following the conventions it was given. And the result? The build is clean, 0 errors, and the entire test suite passes. 73 tests, all green. A working, production-shaped service. Start with the heart of the domain, the order aggregate. It is a state machine. Every transition, like submit or ship, returns a result, never a thrown exception. And a date that might not exist yet, like when it's shipped, is a maybe, not a null. The status itself is not a bare string. It is a smart enum. The set of valid states is closed, so an invalid status simply cannot be represented. The value objects, like quantity, validate themselves once at construction. After that, the type is the guarantee. You cannot pass an invalid quantity anywhere. In the application layer, each command carries its own authorization. Canceling an order checks, right here, that the actor is the creator or an admin before anything happens. The anti-corruption layer maps the domain to the database by convention. There is almost no handwritten configuration. Trellis handles the value objects and the keys. And the controllers stay thin, build the command, send it through the pipeline, and map the result to an HTTP response. You did not write any of this, but now you can read all of it and judge whether the machine got it right. That's the loop, end to end. You scaffold an empty service, handed an AI a precise spec and the framework's conventions, and it built the whole thing: domain, application, persistence, API, tests. Then you did the valuable work. You read it to learn the shape, ran it to see it behave, and reviewed it against a checklist, including the places it fell short, because a green build is not a correct service. And you extended it, and it stayed consistent. Everything you saw is in the training lab repo, this order management lab, plus a background worker lab and a URL shortener lab, each with its spec and checklist. Clone it, run it with your model of choice, and see what it scores and where it slips. If you want the why behind every pattern we skimmed today, the Spec to Working Service series builds this same service by hand, one concept at a time. Link in the description. Go run it.